Okay, so for example, 10.7, we're presented with a mobile sculpture being suspended in a ceiling, and it consists of two metal spheres with a mass of 2 kilograms, and it has a metal rod of 3 kilograms with a length of 4 meters, and it's telling us that it could make 3 revolutions per minute, and it's asking us to find the angular momentum and kinetic energy of the assembly. So basically I did a little setup here of what that would look like visually, right? We have the two spheres here, which is 2 kilograms. The rod is 3 kilograms, with and the total being 4 meters. The length of the rod being 4 meters, and it goes 3 revolutions per minute. Now to find the angular momentum, we have to do the moment of inertia times the work done, possibly. Sorry, not the work done. That's angular velocity times angular velocity, right? And then to find kinetic energy, you do the moment of inertia times the angular velocity squared. And so obviously the first thing we need to do, let's try to find a moment of inertia and angular velocity, and we should have everything we need to find it. Okay, so first, to find the total moment of inertia, we have to find the separate of the sphere and the rod, their own moment of inertia, and then add them together to find the total. So we do that here, right? By knowing that we do that here, and then we find for the spheres, right? We use the 2 times the 2. It comes from the 2 kilograms, and so we use that there, and we get 8 kilograms by meter squared. So that's for the spheres. And for the rods, we find the moment of inertia for the rods, which we do here. We have here the 3 kilograms, which is given, and the 4 meters, which is also given, and we get 4 kilograms by meters squared. Now to find the total moment of inertia, you just add them up. We have the 2 eighths right here of the spheres, plus the 4 that we got before, and we get 20 kilograms by meter squared, and that's going to be our moment of inertia total. Now the last thing we need is going to be the angular velocity, and we have part of that. We just have to now adjust it to rads per second. We have it in revolutions per minute. We do that by just multiplying 2 pi over the revolutions and then converting the minutes to seconds, and we get 0.31 rad per second, right? And that's going to be our angular velocity. Now angular momentum, very straightforward. The 20 that we got from before, from the total moment of inertia, times the 0.31 rads, which we just did, per second. We get it 6.2 kilograms by meter squared per second. That's going to be the angular momentum. And the kinetic energy, it's the same. Basically use the same numbers, except that you square the angular velocity and you multiply it by half. That's the only difference here. So half times the 20, the moment of inertia, times 0.31, and that equals 0.96 joules, and that's it.